Ready-made knitted sacks produced on Russell machines have become a permanent feature of the packaging industry today. The warp knitting technique offers a broad spectrum in product design. For example, both close grain and very open settings can be obtained, adapted to the shape and size of the filling material. This technique makes it possible to work with made-to-measure material, so that making up is not necessary. Even a drawstring and a label for advertising purposes and details of quality and content can be incorporated. Similarly, dimensions such as diameter and length can be adjusted as required. Packaging sacks are manufactured from narrow polyolefin tapes. These chemical fibers have the following advantages in comparison with natural yarns: high tenacity, a low specific gravity, a high covering capacity. They are resistant to petrifiers, tasteless, water repellent, and fully recyclable. The packaging sacks can be manufactured both horizontally and vertically on the Russell machines. For example, the sack opening can be made at the top or at the side. In the most commonly processed type, the sacks run at right angles from the machine so that the manufacturing process takes place as follows. The RDS 11 packaging sack Russell machine has 2 compound needle bars, 4 ground bars, and 7 bars for connecting. On both the compound needle bars, 2 fabric sheets are manufactured, each with 2 ground bars. At certain intervals, which can be programmed via an electronic counter, the 2 fabric sheets are joined together at the sides by changing the lapping of the 2 ground bars. As has just been seen in the diagram, 2 fabric sheets are manufactured here on the 2 compound needle bars using the respective ground bars. For this purpose, the pillar weft inlay shown in this diagram has proved successful for decades. The density and carrying capacity of the packaging sack fabric depends on the chosen gauge and can be additionally influenced by the width of the tape yam and stitch density. As a general rule, tape yams with a width of 1.5 to 2.5 millimeter and a density of 20 to 35 micromillimeter are used. The connecting bars shown in blue produce the packaging sack base seam, thereby connecting the 2 knitted fabric sides. Further guide bars are available for incorporating adhesive tapes to which a label can subsequently be applied, either self-adhesive or heat applied. At the same time, drawstrings and handle strips can be incorporated. The tape yams required for this are supplied by separate creel to the Russell machine. The shogging movements of the ground and connecting bars are controlled by pattern disc. The lateral movement is transferred to the respective guide bars via the shog lever and push rod. Two different systems are available for ensuring the supply of the knitted continuous sacks. The first and classical system is the batching device. The continuous packaging sack sheets produced on the Russell machine are rolled up into fabric batches up to 120 centimeters in diameter. In the manufacture of so-called automatic packaging sacks, these fabric batches are supplied to fully automatic filling machines. The second system is the sack separator. This is fitted directly to the Russell machine instead of the fabric batching device. Here, the sheets are heat separated and stacked by the stacking device. These separated packaging sacks are designed for manual filling. The yams are usually supplied in the warp knitting mill by warp beams. Beaming can be performed using the following methods: film slitting draw warper and beaming unit for feeding primary film, direct warping or direct beaming of fully oriented tape yams from bobbins. Other possible methods are takeoff of fully oriented tape yams from creel, film slitting unit for feeding fully oriented films, EZO system for feeding primary film. FSSB is the abbreviation for the film slitting draw warper and beaming unit. In this unit, a pre-oriented film, also known as primary film, is fed in and cut into tapes. The tape yams, oriented monoaxially, are warped-unwarped beams and then fed to the knitting elements on the Rachel machine. The next system shows direct warping or direct beaming from the creel. Here, fully oriented tape yams are fed from creels and warped directly on warp beams. Here, too, the tape yams are conveyed from warp beams to the knitting elements. Fully oriented tapes on bobbins run from a creel to the knitting elements via feed rollers. This version ensures maximum efficiency but takes up more space. By means of the film slitting unit, rolls with monoaxially oriented film are fed directly to the Rachel machine and cut into tapes, which are conveyed directly to the knitting elements. The tape yam unit shown here is supplied with primary film, which is cut into preset widths. The tape yams thus produced are stretched monoaxially and supplied to the knitting elements exactly as required. The EZO system will be described in more detail. Which of the systems described is used depends on the particular making up of the film or tape available, the factory structure, and the size of demand. The most recent and modern method of manufacturing packaging sacks and tubes was developed by the firm Karl in cooperation with the firm EZO, Maschinenbau GmbH, and various users. By comparison with the offline method, the online EZO method offers the advantage of direct material flow and low space requirements, high product flexibility, and the possibility of adopting the physical parameters of the tape yams to the prevailing requirements. The EZO system has a modular structure and can be supplied as a single unit or as a double or triple block. In each case, each configuration is an independent unit. The number of units required is determined by the machine width, number of guide bars, gauge, and tape width. A double-ply primary film roll is fed in both sides of the EZO unit. If required, a single-ply film roll can also be fed in. For this purpose, an additional film feeding device is available behind the machine in order to obtain the required number of tapes. The film is drawn off from the film roll and passes through the defect and self-ridge scanning device to the film preheating system and self-ridge spreader. The primary film is cut into tapes of previously adjustable widths, which then pass into the drawing zone. The special feature of the EZO system is the preheating comb, in which the tapes twisted by 70 degrees are heated up in the individual heating channels and pre-stretched. Directly behind the heating comb is the draw pin, over which the pre-oriented tapes are given a final stretching. During this process, the molecules are oriented in a lengthwise direction, which gives them their strength. By fixing the stretching ratio, it is possible to influence the quality and fabric weight of the article to be produced. With slight stretching, for example from 1 to 4, the tensile strength of the tape is low, whereas the extensibility is very high. With greater stretching, for example from 1 to 7, the tensile strength is increased and the extensibility decreased. The oriented film tapes now pass through the storage device, which controls the speed of delivery and the yarn tension for the Rachel machine. After passing through the storage device and a preparation unit, the film tapes arrive at the knitting elements of the Rachel machine. After the film roll has run out, the ends are welded to the beginning of the subsequent rolls. An RD8N Rachel machine is also available for manufacturing tubular net packaging for the small portion range of the packaging industry. Like the packaging sacks, the warp-knitted tubular net packaging is also manufactured from polyolefin tapes. These are distinguished by a very low empty weight, an open net structure with variable size, a soft surface due to extremely thin film tapes, their ideal suitability for automatic filling. The film tapes required for the production of tubular net packaging are provided most economically by the ISO unit of the Rachel machine. The tubular net packaging Rachel machine has 2 latch needle bars, 4 ground bars, and 4 connecting bars. As in the manufacture of packaging sacks, 2 separate fabric sheets result on both latch needle bars, with 2 ground bars each in the production of tubular net packaging tube. The 2 connecting bars link the 2 net surfaces, right and left, to a seamless tubular net. The size of the tubular net can be fixed as required, irrespective of the filling, both within the working width and with different widths. The finished tubular nets, up to 300 meters in length, are prepared for dispatch on the gathering machines installed behind the Rachel machine. When the preset length is reached, the gathered tubes are unloaded with previously inserted paper strips ready to be fed to the automatic filling machine without any interruption of production. In this form, the gathered tubes are fed into the automatic filling units. This film is intended to provide a brief overview of the production of packaging sacks and tubular net packaging on Karl machines. Due to its numerous advantages, the Rachel knitting technique has proved its worth in the manufacture of this packaging material in all parts of the world.